Hello and welcome to another video, and in this video I want to continue our discussion about data types in Python. Specifically, I want to discuss Boolean data types in this video. So let's jump right into it. So let's start by defining what a Boolean data type is. In Python and pretty much all other programming languages, a Boolean data type is a type of data that can take one of two possible values. And we usually refer to these values as a true value or a false value. Again, a Boolean data type can only take one of two possible values. It can either be true or false. These are the only values that a Boolean data type can have. And this alone makes Boolean data types vastly different from the other data types that we talked about in previous videos. For example, we talked about strings, we talked about integers and floats, and all of these other data types, you are able to assign more than one value to the type. For example, when we talk about strings, a string by definition is an arbitrary text. So by definition, you can have any text be a string. When we talk about integers, 0 can be an integer, 1, -5, 4. You have many different values that can be of type integer. Same thing with floats. But when we talk about Boolean data types, they can only be true or false. They can't be anything else. And that makes them very different from the other data types that we talked about. Now you might be wondering, why are Boolean data types even useful? Just a data type that takes one of two values, either true or false? When are we going to use this? That is a fair question. But remember, in this video, what we're trying to do is we're trying to just understand the data type in a very pure, fundamental way. How, when, and where the Boolean data type will be used will be more clear in some future videos. Specifically, if we're talking about Boolean data types, when we talk about conditionals, when we talk about something like if statements, if and else, and all of that kind of stuff. If you know what they are, you probably know what I'm talking about. If you don't know yet, because I haven't actually made a video about conditionals, then things will be clearer in the near future. So I'm just laying the foundation for now, but all the dots will be connected in the future when we talk about more advanced topics. So let's have a minute of trivia. If you become an expert programmer and then sometime later in the future, some junior programmer comes to you and asks you, what does Boolean mean? What does the word Boolean mean? Quite frankly, I didn't know the answer to that. I'm a little embarrassed. Until I started making this video, I had to research what is the origin of the word Boolean. And it's actually quite fantastic. So Boolean is coming from a name, from the founder of Boolean algebra. His name was George Boole. So Boole was his last name, and that's why Boolean algebra was named after him. Boolean data types were also named after him. And like I said, he's the founder of Boolean algebra. Boolean algebra is a field in algebra that deals with Boolean data types, the trues and false that we talked about, or you can think of them also as ones or zeros. Remember that it's any two possible values. We just name them true and false. We can also name them ones and zeros. Understanding Boolean algebra is fundamental if you want to understand how the electronic chips in your laptop or in any device, pretty much any digital device, work. So if you've ever studied logic or digital design, pretty much the first few chapters are just talking about Boolean algebra, because understanding them is fundamental to understanding how to design chips. Okay, let's move on. Now that we know what Boolean data types are and where the word Boolean comes from, let's jump to the Python shell and play around with this data type and try to understand it a little bit more. So let's see how this true and false values looks like. So basically true is represented like this and false is represented like this. One thing I want you to notice here is true starts with an uppercase T, and also false starts with an uppercase F. So if you do something like this, this is not going to work. Same thing if you do this. In other programming languages, true and false is written with all lowercase letters. But in Python, remember, the T is an uppercase letter and the F is an uppercase letter. So these are the two values that make the Boolean data type. So as always, let's use the built-in type function to double check the type of true and false. So if you do something like this, type of true, you get that it is of class bool, and bool is short for Boolean. Same thing if you do for false. So type of false is also a class bool. And like any type of data, true and false can also be assigned to variables. So for example, you can do something like this. You can say x is equal to true, and then you can say y is equal to false. Now, if you want to see what's stored in x, you can just type x, you get true, you can type y, and then you get false. And also you can print these values as well. So if you print x, true is printed on the screen, and if you print y, false is printed on the screen. All right, similar to what we did before with numbers and strings, when we talked about operations you can perform on integers, floats, or strings, what I want to do now is I want to talk about operations that you can perform on Boolean data types. Specifically, I want to talk about two different types of operations. The first type is an operation that you can perform on numbers or strings, but these operations will be evaluated to a Boolean value. And then the second type of operation, which we will call logical operations, these operations operate on Boolean data, and then the result is also Boolean data. Let's start with the first type of operations. This type of operations is called comparison operations. Comparison operations because they are comparing two different data. And the operands, the things that these operators, these comparison operators are going to be working on, it could be strings, it could be integers, it could be floats. What are these comparison operators? Let's take a look. So hopefully this is not going to be new to you. The comparison operators are very intuitive. For example, things like greater than, less than, greater than or equal, less than or equal, the equality operator and the inequality operator. These are all examples of what we call comparison operators. Let's take a look how they work in reality. So for example, let's store a value of 5 in a variable called x. And let's also say y is equal to 9. So these are two numbers, and more specifically, these are two integers. So if you do type of x, you get that it is an int. So that's to be expected, nothing new here. What's new here is if we do the following. Let's say y is greater than x. So greater than is a comparison operator. And then the operands, both of them are integers. You have y on the left side, and then you have x on the right side. And like I said, comparison operations, they are evaluated to Boolean data. They're evaluated to true or false. So for example, in this case, y is greater than x. Y is equal to 9 and x is equal to 5. Is 9 greater than 5? The answer to that is yes, or true. So if we press enter, we get that the answer was true. And the way I want you to think about this is basically y is greater than x is an expression. And in theory, you can just completely remove this expression and replace it by the value true. So if I say true, it's the same thing as saying y greater than x. They are exactly the same because y greater than x is reduced to true. Python will convert y greater than x into the true value, and then the program will proceed. What if I had said y is less than x? You get the opposite value. You get that it's false because y is greater than x. What if we say y is greater than or equal x? That's also true because y is greater than x. But if you also said y is greater than or equal to 9, you also get that it is true because y is equal to 9. Now let's talk about the equality operator because there are some nuances here that I want to talk about a little bit. So the equality operator is represented as two equal signs. So two equal signs. This is very important because if you remember when we talked about variables before, we said that if we want to assign a value to a variable, the way we do this is we say, for example, we say k is equal to, let's say, 10. What's happening here is, this is an assignment statement. You're basically assigning the value of 10 to the variable k. there is no comparison operation happening here. But if you say k and then equal 10, this is not an assignment statement. This is not a statement anymore. This is something we call expression. An expression is something that is evaluated to some value. So in this case, k equal 10, you're basically testing if k is equal to 10 or not. This is an expression that will be evaluated to true or false because it's a comparison operation. It's a comparison expression. So in this case, it will be evaluated to true because k is actually equal to 10. It's very important to understand the difference between the equality operator and the assignment operator. The assignment operator is used when you want to assign a value to a variable. The equality operator is used when you want to compare two different values. That's a very crucial difference between the two. And it's also one of the most common mistakes for absolute beginners. In addition to the equality operator, you also have the non-equality operator, which if you want to test the non-equality of two values. So for example, you can say k is not equal to 10. So think of this as you're asking Python, hey, is k not equal to 10? And the answer to that should be false, because we know that k has the value of 10, and that's why we get false. Another thing I want to mention here is comparison operations don't just work on integers. They also work on floats. So you can do something like this. 5.2 is greater than negative 1.3, and the answer will be true. Or you can say 0.0 is equal to 0, and the answer is true. Not only that, they can also work on strings. And when they work on strings, they look at the alphabetical order of the letters. So for example, if you do A is greater than B, you get false because in the alphabetical order, A comes before B. So A is quote unquote less than B. So it's the same thing as the dictionary order. You can say, for example, Kareem is greater than Afternerd, and then you get that it is true because k comes after a. Now that's pretty much all I really want to cover for comparison operations, but now I want to move to something else. I want to move to what we call logical operations. Logical operations are a little different than comparison operations. If you've noticed here, comparison operations worked on things that were not Boolean data types. They worked on strings, they worked on integers, they worked on floats when you wanted to compare two different values. And the result of this expression was a true or false, was a Boolean value. Logical operations, on the other hand, they actually work on Boolean data types. The operands are Boolean data, and also the result is a Boolean data. What are the logical operators that we're talking about? There are three really important ones. Something called the AND operator, the OR operator, and the NOT operator. All of these operators, they work on Boolean data and they are evaluated to Boolean data as well. Let's start with the NOT operator because it's the easiest out of them. So the NOT operator basically changes the value of the Boolean. It flips the value of the Boolean. So if you have true, not true will be false. If you have false, not false will be true. Let's take a look. So let's say x is equal to true, and then let's say not x. So you get false. And if you say not false, you get true. Very simple. So that's what the not operator do. It just flips true into false, and it flips false into true. Very simple and very straightforward. Now, the other two operators that we want to talk about is the AND operator and the OR operator. And these are quite important. So here is how they work. The AND operator is going to take two operands. Both of them are Boolean, and it will only return true if both of them are true. The OR operator, on the other hand, will also take two operands, and it will only return false if both of them are false. Let's look at a table that shows all of the different values that the operands can have and what the result will be. If you look at the AND table, it's very obvious that the only time the result is going to be true is if the first operand and the second operand are true, are both true. any other combination, the AND operation will return false. For the OR operator, it's obvious that the only time the result is false is when both the operands are false. In other words, the OR operation will return true if any of the operands are true. Let's go back to the shell and have some examples just to make sure that these concepts are ingrained in our brain. So as you can see here, if I do true and true, you get true. If you do true and false, you get false. If you do true or false, you get true. So these work identical to what we have studied in the tables that we just talked about. But now let's make it a little bit more interesting. Let's combine comparison operations and logical operations and see how this works. Let's assign the value of 10 to x, and let's assign the value of 20 to y. So x is equal to 10, y is equal to 20. Now let's do the following. Let's say, for example, y is greater than x and 5 is greater than 2. Let's look at the line we have here and see how this will work. So we have an AND operator in the middle, and there are two operands, one to the left of the AND operator and the other one is to the right of the AND operator. But unlike the examples we had before, now the operand to the left of the AND operator is actually another expression, which is a comparison expression. But this comparison expression, we said it's eventually going to be evaluated to either true or false. And similarly, the other operand to the right of the AND operator, eventually, since it is a comparison operation, it's going to be evaluated to either true or false. So at some point, this is just going to be two Boolean data, two Boolean operands, and then you apply the AND operator on them. So y is greater than x is evaluated to true because 20 is greater than 10. And then the other operand, 5 is greater than 2, is also evaluated to true because 5 is greater than 2. So now you have an AND operation where both the operands are true, so the result is true. And why is the result true? It's because y is greater than x and also 5 is greater than 2. Since both these conditions apply, the result is true. But now let's change it a little bit. Let's say y is greater than x, and then we have an AND operation, and then say 3.4 is greater than 10. So in this specific case, y is greater than x. We know that this evaluates to true because y is 20 and x is 10. 3.4 greater than 10. This is actually false. So in this case, we're doing an AND operation between true and false. So the result is going to be false. However, if we do this instead, if we say y is greater than x, and instead of AND, we say OR, 3.4 is greater than 10. Still, y is greater than x. We know that this will evaluate to true. 3.4 is greater than 10. We know that this evaluates to false. But in this case, we're having an OR operation, not an AND operation. Since it is an OR operation, and since one of the operands is already evaluating to true, then the result is going to be true. In other way, think of the OR operation as if you're asking, is any of the condition true? If any of the conditions around me is true, I am going to return true. If the two conditions are false, I am going to return false. So to summarize what we've learned in this video, we talked about Boolean data types, and we said that a Boolean data type is a type of data that can take one of two values, either true or false. And in addition to that, we also talked about two different types of operations. We talked about the comparison operations and the logical operations. Comparison operations work on integers, floating point numbers, strings. It compares these data types, but it's evaluated eventually to true or false, to a Boolean data. Whereas the logical operations, they actually work on Boolean data, and the result of the expression, the result of the operation, is also Boolean data. So with that, I think I've pretty much covered everything that I wanted to cover in this video regarding Boolean data types. In the next videos, we will be talking about more advanced topics, specifically how, when, and where can we use all of these data types that we've been talking about? So have a good day, and I'll see you in the next video.